This is pre-algebra lesson 8-3, slope and y-intercept. We're going to graph y equals x, y equals 2x, and y equals 3x on the same coordinate plane. And we're going to explore them and look and see how they are the same and how they are different. So let's graph y equals x. All three of these we can use negative 1, 0, negative 2, negative 1, 0, 1, and 2. Negative 2, negative 1, 0, 1, and 2. Because they're on the directions. Okay, so for y equals x, okay, so if x is negative 2, y is negative 2. Okay, if x is negative 1, y is negative 1. If x is 0, y is 0. If x is 1, y is 1. And if x is 2, y is 2. I'm going to graph that one in purple. So negative 2, negative 2. Negative 1, negative 1, 0, 0, 1, 1, 2, 2. And I'm going to graph this. And I'm going to try to do it in purple. So kind of less color, I think. So if I draw this line, it's kind of purplish. Okay, let's see. This line a little straighter here. There we go. So that's the equation of y equals x. Very important that we label which equations are which once you have more than one equation on a graph. Now this equation is y equals 2x. Okay, so I'm going to have 2 times negative 2, which makes that negative 4. 2 times negative 1, which makes that negative 2. 2 times 0, which makes that 0. 2 times 1, which makes that 2. And 2 times 2, which makes this 4. So I'm going to graph those points. So negative 2, negative 4. Negative 2, negative 4. Negative 1, negative 2. 0, 0. 1, 2. And 2, 4. And I'm going to plot those on my graph in blue. So here's the graph of that line. And then we'll put my arrowheads on that. If you remember, that's the equation of y equals 2x. So that's y equals 2x. Last but not least here, we're going to do y equals 3x. So that's going to be 3 times negative 2, which is negative 6. 3 times negative 1, which is negative 3. 3 times 0, which is 0. 3 times 1, which is 3. And 3 times 2, which is 6. So I'm now going to plot those points. I can't plot negative 2, negative 6, but I can plot negative 1, negative 3. I can plot 0, 0. I can plot 1, 3. And I can't plot 2, 6. So I'm going to graph these 3 on my graph. Green. So there's that graph. Okay. There we go. Lock that in place so it can't move. Add my arrowheads to that one. And this is y equals 3x. So if you look at these, how are these graphs alike? Well, if you look at them, they all three go to the origin, through the origin, don't they? All three of them go through the origin. How are they different? Well, some are steeper than the others. The purple line is the least steep, the blue line is middle steepness, and the green line is the most steep. If you look at this, we have three equations. Y equals x, y equals 2x, and y equals 3x. This has the steepest slope. It's the steepest line, and this is the least steep line. So if you were having to bicycle up these hills, I picked the purple hill because it's less steep. Okay. They both go to the origin. One, there's a little less steep than the other. Okay, let's take a look at some other graphs. And we're going to graph y equals x and y equals negative x on the same coordinate plane. Okay, so y equals x, and y equals negative x. So again, I can use negative 2, negative 1, 0, 1, and 2. So, if y equals x, if x is negative 2, y is negative 2. If x is negative 1, y is negative 1. If x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. No middle meaning of my table, is there? I'm going to graph that. Y equals x again. So we have negative 2 is negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2. If I plot this, I just do a graph this. Purplish, I can get it more purplish. There we go there. There's my graph of y equals x. Now let's look at y equals negative x, or the opposite of x. If x is negative 2, negative negative x is positive 2. Negative negative 1 is 1. Negative negative 0 is still 0. The opposite of 1 is negative 1. The opposite of 2 is negative 2. So now, when x is negative 2, y is positive 2. When x is negative 1, y is positive 1. And when x is 0, y is 0. When x is 1, y is negative 1. And when x is 2, y is negative 2. So if I was going to plot those lines, there. I'll put my arrowheads on my line, and this is y equals negative x. What do you notice about these graphs? They both go through the origin. However, the purple line goes up and to the right, while the green line goes down and to the right, which means their slopes are different. Okay? How you go up and over, okay, for example, if I was to go here to here, I'm going up and to the right. On this graph here, if I pick a point, I'm going down and to the right. Okay, so the slope of the purple line is up and to the right, and the slope for the green line is down and to the right. Okay? The ratio that describes the tilt of a line is its slope. If the line slants upward from left to right, then the slope is positive. If the line slants downward from left to right, then the slope is negative. Let's go back to this graph for just a second. Think of yourself, okay, walking from left to right. We read from left to right. Think of yourself walking from left to right. If you got to the purple line, you'd have to go up. It's a positive slope. If you started walking and got to the green line, you get to go down, so it's a negative slope. You're sliding down the green line, you're walking up the purple line. Therefore, the purple line has a positive slope up and to the right. The green line has a negative slope down and to the right. You're sliding down or you're climbing up. That's the easiest way to remember it. Slope is the measure of the steepness of a line. You can find the slope in many different ways. If you know 2 points of a line, you can find the slope of the line by following the following formula. The change in your vertical divided by the change in your horizontal, sometimes referred to as y's over run. The difference in your y coordinates or the difference in your x coordinates. We're going to find the slope in several different ways. Okay? Let's take a look at these 3 graphs. We're going to find the slope between these 3 graphs. Since we read from left to right, we're going to read until we get to the first point. Here's my first point right here at 0, 3. Slope is rise over run or fall over run. So you're always going up or down first. So the first thing I do if I read, I have to go down and I have to go to the right. I went down 3 units and I went to the right 2 units. So the slope of this line is 3 over 2. They use the abbreviation M for slope. You might wonder why in the world they use the abbreviation M for slope. That's because the mathematician who determined slope was French. His name was René Descartes. Okay? And Frenchmen use French language when they're describing things. And the word for slope in French is montier, it means to mount. And so the abbreviation for montier would be an M, which is why we use an M for slope. Okay? So the slope here is 3 over 2. Okay? It's not positive 3 because we went down 3 units, so it's a negative 3 over 2 slope because we went down 3 and to the right. If we look at our second graph, as we're walking down the graph, we get to point A first. We're going to go up 2 units, and we're going to go to the right, it looks like 4 units before we get to the point B. So the slope here would be rise, which is 2, over run, which is 4, which you reduce to 1 over 2. You never change slope to a mixed number. You never use it as a decimal. It's either a whole number or it's a fraction, improper or proper. You never ever change it to a mixed number. So the slope of the second graph is 1 over 2. Because if I looked at it, I'll go up 1 over 2, up 1 over 2, up 1 over 2. It's like climbing stairs. Let's look at graph number 3, or C, I should say. As we read from left to right, we get to point B first. We're going to have to go up and over. We went up 1, 2, 3 units, and we went over 1, 2, 3, 4, 5, 6 units. So the slope would be up 3 over 6, which reduces to 1/2. And if we look at that, we can pick any point. Let's take this point here. If I go up 1 and over 2, look, I'm on the blue line. If I go up 1 over 2, I'm still on the blue line. So my slope is 1 over 2. Finding the slope from a graph is actually fairly simple. Finding a slope from other things other than a graph can be a bit more cumbersome. Okay, the y-coordinate you use first in the number must, okay, we're going to find slope using points. Okay, the important thing about slope is it's the change in your y-coordinate over the change in your x-coordinate. Okay, so it says the y-coordinate you use first in the numerator must correspond to the x-coordinate you use first in the denominator. In other words, if you find the difference of the first y-coordinate and then the second y-coordinate, you must find the difference of the first x-coordinate and then the second x-coordinate. Easiest thing to remember, slope is found as the difference in your y over the difference in your x. Sometimes referred to as y2 minus y1 over x2 minus x1, or referred to as y1 minus y2 over x1 minus x2. The little subscripts only mean the value, the coordinate. For example, y2 means the y-coordinate of the second point. y1 means the y-coordinate of the first point. x1 means the x-coordinate of the first point. x2 means the x-coordinate of the second point. I tell people the easiest way to find slope when you're given points is simply line up the points vertically. I have B here as being 8, -1, and Q being 0, -7. So I'm going to write 0, -7 right underneath this. It's the change in y and the change in x. Do this if you have to make sure you're doing them correctly. Okay? Now that I have them lined up, I'm just going to subtract y over x. So y is going to be -1 minus a -7. All I did here was line up my y coordinates right here. And then I'm going to line up my x coordinates right here. Since I went y coordinate top to bottom, I have to go x coordinate top to bottom. So it's going to be 8 minus 0. 1 minus a -7 becomes -1 minus a -7 becomes -1 plus 7, which is 6. 8 minus 0 is 8. Reduce this becomes 3/4. Okay, so my slope for that point is 3/4. If you line them up correctly, they're not hard to find slope. Okay, it's just being able to line them up correctly so that you can find the difference of your points. And let's look at the next one. S is -4, 3, and R is -10, 9, so I'm going to write -10, 9 right here. Okay, so the difference in my y-coordinates over the difference in my x-coordinates. So my slope equals the difference in my y-coordinates, that would be these guys. So in my case, 3 minus 9, watch your signs, it will be the death of some of you. Over the difference in my x-coordinates, in this case, -4 minus a -10. Minus a minus becomes plus, so you'll have to do that. So this becomes -3 minus 9 is -6. -4 plus 10 is +6. So my slope is -1 or -1 over 1. Either one works. You can leave it as a whole number or you can leave it as a fraction. You just cannot leave it as a mixed number. Let's find the slope between the next 2 points. Okay, 7, 5 and -2, 0. Okay, so my slope is going to be 5 minus 0 over 7 minus a -2. 5 minus 0 is 5. 7 minus a -2 is 9. So my slope is 5/9. Okay, so I'm going to go up 5 units and to the right 9 units. That's exactly what it means. And we have some more slopes. Okay? I'm going to just write them down again. Now these ones get interesting. Okay? Here I have line up my x values, my y values. My change in y, 2 minus 2, over my change in x, negative 3 minus 1. 2 minus 2 is 0. Negative 3 minus 1 is negative 4. I have a 0 on the top of a fraction. Whenever you have a 0 on the top of a fraction, that means it's 0. I am rising none and running like crazy, which means I have the slope of my line is 0. Whenever I have a slope of 0, okay, whenever I have a slope of 0, that means I have a horizontal line. When slope equals 0, this is a horizontal line. Which means you're never rising, always running. Flat line. And that's what it means. The slope is 0. It's another way of saying it's a horizontal line. Let's take a look at this next one. If I line up my points, I have my change in my y values, which is 3 minus a negative 2, over the change in my x values, negative 4 minus a negative 4. This becomes negative 3 plus 2 is 5 over, this becomes 0. If you put 5 divided by 0 on your calculator is going to tell you error. Because you can't divide by 0. Division by 0 is undefined. So whenever you get a 0 on the bottom, this becomes what we call undefined. It is not 0. It is simply undefined. And an undefined slope is the slope of a vertical line. Which means that I'm always rising and never running, which means it's a vertical line. If slope is undefined, it's a vertical line. So if you have a slope of 0, it's a horizontal line. If you have a slope that's undefined, it is a vertical line. Now, what can we do with slope? You can use slope to help you graph equations. You're going to find if you know the slope and y-intercept of something, you can graph something very easily. When an equation is written in the form of y equals, it's actually written in what we call slope-intercept form, or y equals mx plus b form, where the number in front of x is your slope, and the last number being the point where the graph crosses the y-axis. You can use this form of the equation to graph without having to make a table of values. Okay? It makes the graphing so much easier. Simply follow the following steps. You're going to graph the y-intercept first. This point will always have 0 for the y value. Since you cross the y-axis, the y value must be 0. From the y-intercept, you count up and to the right if your slope is positive, or down and to the right if your slope is negative. For example, if your slope is 3/5, there's supposed to be a fraction in there. If your slope is 3/5, okay, put 3/5 in there. You will graph the y-intercept, and from the y-intercept, count up 3 spaces and write 5 spaces and place the point. From that point, you count up 3 more spaces and write 5 spaces and place another point. And you have 3 points, connect the points to label your graph. I'll go through some examples to make this easier. Okay, we're going to graph the following using slope and y-intercept. I'm going to graph y equals 3/5 x plus 6. First thing you have to do is you have to be able to identify your slope and identify your y-intercept. Okay? This is in the form of y equals mx plus b. The m is your slope, and the b is what we call your y-intercept. It's the point where your graph crosses the y-axis. So you need to be able to identify those. So my slope in this equation is 3/5 because it's whatever's in front of x, and my y-intercept is 6 because it's whatever's after the term that has the x to it. Okay, so the first thing I'm going to graph is my y-intercept. My y-intercept is 6, which means it crosses the y-axis. This is my x-axis. This is my y-axis at 6, which right here is there. Okay, and my slope says go down, it should be up 3 units and to the right 5 units. This is kind of hard. So I think what I will do here is I'm going to redo my x and y-axis. Okay? Don't like this. So we're going to just adjust this. This is now my x-axis. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can do that whenever you want to. We dropped our x-axis way down here so that I can graph this. My y-axis crosses my y-intercept at 6. Then I'm going to go from this point at 6, I'm going to go up 3 units. 1, 2, 3, and to the right 5 units. 1, 2, 3, 4, 5. There's my next point. And I would continue doing that and draw a straight line. You really only need 2 of them. Okay, but I always tell people it's probably better to have 3 of them to make sure that you didn't do something wrong. So there's my graph. I'm going to lock this in place here. And I'm going to put my arrowheads on it. And of course, I'm going to label it. Y equals 3/5 x plus 6. The second one here, we have y equals negative 2/3 x plus minus 4. Let's make that a plus 4 because it's going to work out better. Let's do y equals negative 2/3 x plus 4. Just change that on your paper to a plus 4. So my slope is negative 2/3. My y-intercept now is positive 4. It's going to work better with this graph. So the first thing I'm going to plot is my y-intercept. It crosses my y-axis at 4. My y-axis is my up and down axis. It crosses at 4, which means x is 0 and y is 4. That's where it crosses the y-axis. Now I'm going to plot my slope. My slope is negative 2/3. So from this point, I'm going to go down 2 units and to the right 3 units. 1, 2, 3. From that point, I'm going to go down 2 units and to the right 3 units. 1, 2, 3. Okay? And then I'm going to draw my line. Kind of pop a little bit on my line here. Straighten it out a bit. There we go. I'm going to put the arrowheads on it. And I'm going to label it. This is the line of y equals negative 2/3 x plus 4. Remember, we changed that to plus 4. It's very simple to graph an equation in y equals form if it's in slope-intercept form. Very, very simple. No more table of values needed. Right? And of course, if an equation is not in y equals form, you can simply put it in y equals form to be able to write your equation. Okay? Put it in y equals form to write your equation. So that's slope, and that's graphing using slope and y-intercept.